I got my Ender 2 Pro mostly for the purpose of making twisty puzzles, with my first ever print on it being this magnetic 3x3x2 speed cuboid, which I will be calling the Lai 332M. The printer itself is just a basic stock Ender 2 Pro. I just tightened one bolt, like really near the extruder. The most popular model, at least for this price point, is the Ender 3 V2 and like M, because magnetic print bed, which my printer also has. The Ender 2 Pro is just cheaper with fewer assembly steps, but in exchange, its print volume is a lot smaller, which some 3D print hobbyists may view this as a big minus point. For me, however, I don't really care since cube parts aren't that big, with most cubes ranging around like close to 60mm, if not just slightly bigger, and a few that are close to like 70. Monstrosities like this one are not that common, and cube mechanism is very symmetrical in nature, which means that it's unlikely that a part will be bigger than half the puzzle, so it's unlikely that I'll print something bigger than 3 centimeters tall and like wide and so on. There are a few recommended mods to the Ender 3 V2 which can also be done to the Ender 2 Pro, such as a spring swap and switching to a brass nozzle, which I haven't done yet, but I might eventually end up doing. I'm no 3D print expert and I only have one printer, so my opinion about whether this printer is good or not doesn't really give a good idea of whether this is the best on the market. And the only comparison I can have against this FDM printer are my previous puzzles that are printed in SLS printing technology. So at most I can only compare the technology of FDM versus SLS. So fused deposition modeling, or FDM, has two main parts. One of them melts the plastic, which will solidify after coming out of the nozzle, and the other one moves the nozzle around so that like when the plastic solidifies, it will solidify in a predetermined place. So like printing each layer is kind of like a 2D print, where like the x-axis, which is this entire horizontal track here, and the y-axis, which is what the bed is sitting on, is actually sitting on this other piece here, which is a track that goes all the way to the back. So y-axis is in this direction, x-axis is in this direction, and it will print like a regular 2D paper print page. But instead of moving to the next page, it moves on to the next layer on the z-axis, which is this vertical pillar here. So every time it's done with one layer, this thing will move up slightly and print the next layer on top, which leads to the first problem: you can't print on top of nothing. So if your piece has an overhanging part like that, you will need to print another structure known as a support structure. It looks something like that when it's printing, and then you plug away this part, which leads to a problem of you using up more plastic, because this thing also consumes plastic, and also the part where you plucked out the support material will mostly leave a scar, which I've sanded away. The roof of the piece is also an overhanging part. If your piece is hollow, the middle of that roof is also going to be printed on top of nothing, so you need to put a support material there. In this case, it's a specific class of material known as the infill. Adds weight to the puzzle if it's there, and you can actually choose zero infill, but once again, the rules may not print properly, and at the same time, you may also like weaken the piece with less material strengthening it on the inside. So even when I hollow the piece, I don't completely hollow it. I still put a little bit of like support bridges inside. And finally, there's another problem called stringing, where when you're printing two different pieces at two different parts, for example, or if your piece is a U shape, there'll be an intermediate point where nothing is supposed to be printed, but when the nozzle is traveling from like one solid part to another solid part, sometimes a little bit of plastic can leak out of the nozzle and it will solidify into a string. If you are 3D printing a sculpture, this could be really annoying because it really affects the look of everything. But when it comes to just printing puzzles itself, like as long as the quality of the puzzle is there and it doesn't really affect the turning or the performance, I don't really see stringing as that big of an issue. You can actually reduce stringing by printing at a lower temperature, which I did. The default temperature is 200 and I printed at 195 degrees Celsius. In comparison, the other technology is selective layer sintering, or SLS, and it's a newer technology. It happens over a surface of powder, where a laser is used to fuse powder together in one layer, which is then lowered and the next layer of powder is fused on top of it. So this actually eliminates the support material problem, because you're actually not printing on top of nothing. You're printing on top of like powder that won't be fused to your final model. The problem of requiring infills just to print the roofs of any flat pieces is also like mostly overcome, because like you can actually design your pieces hollow such that any powder trapped inside doesn't end up inside the final puzzle. You can flow out through the holes you have put in the piece. But then the problem is SLS printing is much more expensive. It basically cost me about as much to design every part of this puzzle and order it off a SLS print website as compared to buying this entire printer as a whole. When it comes to the actual print quality of my Ender 2 Pro, I'm just going to review my 3x3x2 as a speed cube. That's why I even got the printer in the first place. I'll be beating this puzzle against the Qi 3x3x2. Like, this is a puzzle I borrowed from CubeWorks just for the sake of a comparison, and in my opinion, this is already the best mass-produced 3x3x2 cuboid. Like, the only other 3x3x2s that I know of are the Lan Lan and the Fangxin, and both of them are just a lot slower and much more stiff than the Qi, and don't really offer serious competition. I think if you really want to get yourself a good 3x3x2, I think this one is pretty much unrivaled. Basic specs: the Lai 332M measures 60 by 60 by 50, which is about the same size as the Qi 3x3x2 lengthwise, but height-wise is significantly taller because the Qi has proportional QBs. I can tell this is 40, this 60, so every QB is 20. For this one, it's the same size lengthwise, but height-wise it's a lot bigger. The advantage of this is it's actually a lot easier to finger trick, because like this one, the layer is smaller, your finger has to be in a more precise position. It's also reasonably stable and fast, and turns at a comparable speed compared to the Qi. Although the Qi is a lot smoother, while the Lai S is much crunchier due to the material. When it comes to corner cutting, this one has the best one I've ever seen in a 3x3x2. You can cut like 1 QB forward, and maybe just slightly under 1/3 reverse. For the Qi, at best it's just about 1/4. And for reverse, it's about 1/8. The springs of the Lai 332M are quite strong, and they actually pull the puzzle back into cube shape when I'm turning fast. And it gives this puzzle quite a snappy feel. Not snappy as in the magnets being overly strong, but snappy as in like it just snaps back into cube shape whenever I deform it. So overall, I do find that a lot of basic cuboid triggers, such as the front corner insert and the back corner insert, they're much more reliable and a lot faster than what I can perform on the Qi, although this one isn't bad either. But like, I can feel the stiffness of the puzzle when using this one, whereas for this one, I don't really feel it at all. The Lai 332M is built with the mechanism of a Moyi Weilong 3x3. It also comes with the stockless center design, which is part of the inverted center stock. Unfortunately, some of my internal center stocks actually broke because like I have to make them small enough to accommodate the spring on the outside, but the screw on the inside also has a thickness, so there's really a limit to how big I can print, and like the material isn't that strong. Some of the stocks, not all, actually broke during assembly, but other than that, I do think that the performance of this puzzle isn't really that compromised that badly. And also you can see the core here. This is a green core, so it actually came from the Valk 3. This puzzle has magnets, so the corners have a press fit magnet. The edges, the magnets are not visible, but they actually, if you can see 2 holes right here, the holes are actually quite deep. They go all the way down into the piece, and then just slide the magnet all the way in and drop some super glue in there. Some of the minor things about my cuboid is that it's stickered with red below and orange on top, and that's mainly because I solve on red cross on most of my cubes. The logo sticker is specifically on the alignment piece, so since I use a mechanism of a 3x3 and hit the middle layer, a normal 3x3 will run into the issue of the middle layer coming out of alignment and potentially jamming the puzzle. The problem is very easily fixable if you're trying to make a 3x3x2, because you only need to keep the puzzle aligned on one axis, and you can basically just glue this edge to this corner right here and it will never misalign. It will always turn like that. And even if you were to flip this layer around, now it just follows the top, but the middle will never misalign. But since I'm designing a puzzle and not modifying an existing 3x3 into a 3x3x2, I basically just design one piece where it consists of a corner and the internal edge piece fused together from the start. And that's the very piece that I decide to stick my logo on. So even if the puzzle is fully assembled, I can actually tell where the alignment mechanism is and which side the hidden middle layer is going to follow. Because if I flip it upside down, now it goes with the top. And if it's upright like that, it goes with the bottom. The main downfall of this puzzle is the plastic quality, which obviously doesn't match with the injection molded ABS. This is so smooth. FDM printed PLA feels extremely hard and scratchy. And this is also like hands down the loudest puzzle in my entire collection, partly because of how rough it is and partly because of how hollow I designed the pieces to like lighten the puzzle. But compared with my SLS printed nylon powder, like printed puzzles, however, I actually like FDM PLA better, or at least I think it has more potential. So SLS, even though it's the superior 3D printing technology, it uses a material that essentially begins as a powder, giving the puzzle a very sandpapery feel, which I'm not the greatest fan of. And on the other hand, the scratchiness of the FDM print mostly boils down to the stepping pattern. So you can see a lot of lines here, and that's caused by one layer being printed on top of the others. And like the higher the resolution, like the lesser this line pattern is going to be, which is why this one, even though it's also kind of a layer by layer print, but SLS resolution just a lot better, so I can hardly even see lines on my SLS puzzles. But for my FDM puzzle, I definitely have a little bit of this line problem, and I think I can actually minimize this problem based on how I angle the pieces. Like if I can just make the lines like parallel to the rotation instead of crossing the rotation like every single time, I do think I can get this puzzle to turn smoother. So in conclusion, I'm actually really satisfied in how this print went. The puzzle isn't perfect, but unlike all my past 3D prints where they are mostly proof of concepts, like this one is actually good, and I would actually say if I had to choose between this and the Qi 3x3x2, I'll probably use this. I think it's just overall better for speed. Although that's partially due to the market lacking a good 3x3x2 because this is not a WCA event, whereas my 5x5 on SL Sprint doesn't feel that great because there's so many good 5x5s on the market, and like manufacturers put serious effort into making really good 5x5s. With a 3x3x2, it isn't really that difficult to beat the best puzzle on the market, even without comparing with the market. Like, I feel that on its own, this puzzle can handle fast-paced algorithm execution with reasonably good reliability. And I feel that also my knowledge of FDM printing is, like, as of now, just a small tip of the iceberg. I'm confident that if I learn more about FDM printing, I can figure out ways to minimize all the things I don't like about it and make a puzzle even better than this one.